Today we're going to talk about solving a system of linear equations by substitution. If you recall, previously we talked about solving systems of linear equations by graphing, and so this was one of the homework problems we did. I'm going to go ahead and graph this. So y equals 2/3 x plus 3. The y-intercept was 3. From there I'm going to go up 2 over 3, making sure my line is going to be going in a positive direction. And then I'm going to draw my line. For my other graph, the y-intercept is -4, so I plot -4 on the y-axis. The slope is -2, so I'm going to go up 2 and to the left 1, making sure my line is going in the negative direction. I'm going this way because I'm trying to find where the two lines cross. And that's not a very straight line. Sorry about that. So I want to estimate where these two lines cross, because that's the solution to my system of equation. That value of x and y makes both equations true at the same time. So it looks like it's about -2.6 maybe, and about 1.2, close to that. But it's kind of hard to tell when you're doing this by graphing. If it doesn't cross right at a grid point, then you're not really sure if that's the answer or not. So a better way is to solve it algebraically. Now remember, I said that the solution makes both equations true at the same time. The x value and the y value have to be the same. So what we can do when we have both equations set equal to y, so we have y equals 2/3 x plus 3, y equals -2x minus 4, then it must be true that 2/3 x plus 3 has to be equal to -2x minus 4. So when both of them are set equal to y, we can just substitute these two values and say that they're equal to each other. Now I'm going to solve this for x. We've done these before. I'm going to use fraction busters to clear out my fraction. I'm multiplying everything by 3. The 3's cancel, leaves me a 2x. 3 times 3 is 9. 3 times -2x is -6x. 3 times -4 is -12. Now I just solved the equation for x, so I'm going to add 6x to both sides. And I'm going to subtract 9 from both sides. And we get 8x equals -21. And dividing both sides by 8 gives me x equals -21/8, which is 8 goes into 21 2 times, so we get -2 with 5 left over. And that's about, if you check it on your calculator, 5/8 is 0.625, so we get -2.625 compared to what we thought it was, so it's close, but now our answer is exact. But I'm not done yet. I have to find the corresponding y value. So I'm going to substitute x equals -21/8 into either equation. Now, I should get the same y value for either equation, so I guess if you really wanted to be sure, you could plug it into both. Doesn't really matter which one you substitute it into. I'll go ahead and use the y equals -2x minus 4. So in place of the x, I'm going to put -21/8. And think of this as over 1. 2 goes into 2 once. 2 goes into 8 4 times. So we have y equals negative times negative is positive, so I get 21/4 minus 4. You could use a calculator if you needed to. If I needed to make this a denominator of 4, I get 16/4, so 21/4 minus 16/4 is 5/4, which is, by the way, 1.25. So if you compare that to what we thought it looked like it was about, we thought about 1.2, so you can see that we were close, but this is a better answer. So now I know that they cross at -21/8 and 5/4. So this is my solution to the system of equations. Here's another one. This one's going to work out a little simpler for us. We won't have all the fractions, but both of them are set equal to y, so I can set them equal to each other. So I start with negative 2x plus 4 equals x plus 1. So it's the same first step. Now I'm going to solve for x. So I'm going to subtract x from both sides, and I'm going to subtract 4 from both sides. So I get negative 3x equals negative 3. And if I divide both sides by negative 3, I get x equals 1. Remember, I'm not done yet. I still have to solve for y. So remember, to solve for y, I substitute this value into either equation. I'm going to put it into the second one. So I get y equals 1 plus 1, which is 2. So my solution is the point 1, 2. And that is the solution to the system of equations. What that means, if I plug in the value for x and y, and x equals 1, y equals 2, it makes both equations true at the same time. Also, what that means, if I graph these two equations, they will cross at the point 1, 2. If you want to, you can pause this and try this problem on your own, and then check back and I'll work out the solution. So start by setting them equal to each other. Then I'm going to subtract 2x from both sides and subtract 5 from both sides. So I have negative 6x equals negative 12. Dividing by negative 6, I get x equals 2. Not done yet. Have to solve for y. Plug it into either equation. I'm going to use the second one. 4 minus 7 is negative 3. So my solution is the point 2, negative 3. You can check your answer by substituting a 2 in for x and a negative 3 in for y, and making sure that you get a true statement. You can do that for both equations, and you can check that. Okay, let's try this one. Now you'll notice, take a look here and see what's different. Well, notice they're not both solved for y. Now, if you want to, you could take the first equation and you could solve for y. But I don't want to, because I'm going to do it another way. When one of them is already solved for y and the other one is not, then what I recommend you do is take this value that is equal to y, and we're going to plug it in place of the y. So when I do that, take your first equation, negative x plus 3, and instead of the y, I'm going to put what y is equal to, negative 2x minus 7. Again, so notice what I did. This is actually the first equation. This whole thing that I wrote is the first equation. But instead of writing a y, I substituted what y is equal to. Y is equal to negative 2x minus 7. So this is like having negative x plus 3y equals 0. So now I can simplify this. I'm going to distribute the 3, and we get negative x minus 6x minus 21 equals 0. Now these are on the same side of the equal sign, so I combine like terms, get negative 7x, and I'm going to go ahead and add the 21 to both sides, and divide by negative 7, and I get x equals negative 3. Remember, I'm not done yet because I need a y value as well. So I'm going to substitute it into the equation that's already solved for y. And I get 6 minus 7 is negative 1. So my solution is negative 3, negative 1. Again, that means if I graph these two lines, they're going to cross at the point negative 3, negative 1. If I substitute these values in for x and y, it makes both equations true. All right, as we go on to the next example, I'm going to have a part 2 of the video, so you'll need to watch the next one.